Good morning, ladies and gentlemen. Welcome to this video on simple compound interest. And to start off with, we're going to look at Banking 101, how banks make their money fundamentally. You don't need to take notes on this bit, just start taking notes when we reach up to the simple interest part. Alright, so the way banks work is a bit odd if you really think about it, because you might give a bank $100 to look after, and so might the next person, and the next person, and the next person. And the bank does a couple of things. Firstly, it lets you access your $100 whenever you want, wherever you want. From ATMs, on the internet, on the phone, it creates apps for you to use. It lets you guarantee the safety of this $100. And you think that for all those services, the banks would ask for money, but they don't. Instead, strangely enough, they give you money in return. So if you leave the $100 in the bank for a year, they might give you 3% back. So they will give you $3 back, $3 back, $3 back, $3 back. And it sounds absurd that the bank would pay you money in order to look after your money. They're doing you a favor and a service by looking after your money, keeping it safe, letting you access whatever you want, and they're paying you to do that service. So the question is why? Why would the banks do this? Well, the banks have this amazing business model where they take those hundreds and they find a big happy family and they say this big happy family wants to buy a house. Well, the family needs money to buy a house, so the money they've collected from all these deposits doesn't stay in the bank. It gets lent on. I've oversimplified the process. In reality, the banks would lend far more than they take in deposits, but let's keep it at this, and clearly you need more than $400 to buy a house. And what they do to the family then is they say, okay, we'll lend you the money so you can have your house today, but you've got to pay us interest. And rather than 3% interest that we're paying to these people, you've got to pay us 5% interest. So what happens is this family, for the pleasure of having the $400 now, pays 5% interest, which is $20 a year back. And what the bank is happening, it's paying out $3, $6, $9, $12 in interest to borrow people's money. So when you deposit money in a bank, the bank's borrowing the money off you, and then it lends it out, receiving $20 from the mortgage payments. And what happens here is that is called the interest rate gap, and that fundamentally is how banks make their money. Sure, banks charge some fees and services, they charge for interest rates, etc., but fundamentally the gap between what they pay in interest and what they charge in interest is where banks make money, and that is Banking 101. So what I'm hoping is going forward, you should understand that interest payments are the amount paid for borrowing the money. Alright, now, simple interest. In reality, I'll be honest, simple interest isn't used very often in the real world. It's used for things called bonds, financial instruments called bonds, short-term loans and investments, and some types of bank accounts. Annoyingly enough, it's also the one we'll be using in our number internal. So simple interest is the one that we'll use for our maths. In reality, compound interest is used far more often. So we'll look at that a little as well, because it's interesting to know, and the maths behind it is a little more fancy. So if you want to use it in the internal, you could show it off a little. Alright, firstly, compound interest is used with credit cards. It's pretty good for modeling shares and income from shares. It's used for car loans, mortgages, and for most types of savings accounts. So if you go into the real world and get any of these things, then, or even KiwiSaver as well, then chances are compound interest is a good way to think about it. Alright, moving on. So, simple interest. There's a formula. This here is a key formula. That is interest. So the amount paid in interest is equal to the principal. Principal is the amount of money put into the bank or taken out from the bank originally. Up above, it was 100 for each couple, 400 for the family. The rate is the percentage rate expressed as a decimal. So 3% expressed in decimal will be 0.03, for example. And time is expressed in years. That's important. Now note, we can rearrange this formula to get P by itself, well, it doesn't like that top, T by itself or R by itself. Essentially what we're doing is we're dropping the other values under. So we can solve for principal, time, or rate, or interest, all using this same formula. An example might be, how much interest is earned on an investment of $4,500 over 18 months at 3.7%? So what that is saying, if our interest formula is I equals P R T, we then want to calculate interest. This is principal. That's the amount put in the bank. Rate is the percentage rate. And time is that one there. So when we substitute in the formula, we just have to make sure that we're converting it into the correct units. Principal stays as dollars. That's easy. Times. Now, next is rate. Rate is 0.37%, so as a decimal, that's 0.037. And then it's multiplied by time. Lots of students would put 18 for time, or they would think it in years and put 1.8 years. But remember, 18 months is not 1.8 years. 18 months is 1.5 years, so 1.5. And that's the calculation that we're after. Whoop, apologies. So if we chuck that in our calculator and get the answer out, we would say I equals 249.75. So what happens here is, if you put this amount of money for a year and a half in a bank account, at the end of the day, at the end of the 18 months rather, you get back the $4,500 plus $249. Alright, how long to the nearest month would it take $5,000 in savings to earn $200 in a bank account earning 5.1%? Well, here, it's asking how long. So we're using the time version of the formula. Time equals I over RP. Remember up above? Time equals I over RP, or PR. I over RP. So time is equal to the interest earned. Interest earned is 200. So 200 over 5,000. Over the rate, 0.051 times the principal, 5,000. Remembering that we've converted the rate into a decimal. So 200 divided by 0.051 times 5,000 is 0.7843 years. Now note, 0.7843 years, we've asked the nearest month. So you then need to times that by 12 to convert it into months. Not 10, 12. So that is 9.4 months. And here you'd have to rely on the context of the question. It would round to 9, but at 9 it wouldn't earn $200. You could instead round to 10, in that you'll have earned at least $200 after 10 months. Alright. Excuse me. If a $5,000 loan charged 4% over 5 years, 2.5 years, and it was repaid weekly, how much would have to be repaid each week? I'll say that. Alright, so here is a bit interesting. Get it. We have to calculate interest first, and then we're going to figure out how much we owe in total and how much we're going to pay each week. Alright, so interest is equal to PRT. Principal is 5,000 times rate, which is 0.04, times time, which is already in years, so that works out quite nicely. So 5,000 times 2.5 times 0.04 is $500. That number's working out quite nicely. So the total repaid week would be equal to 5,500 over the 130, which equals $42, and you would round this up to 1 cent. $42.31. Now, that is the answer, but if you get a similar question, that would be expected in the internal. However, it's not strictly accurate for the real world. In the real world, as you repay the loan, week after week, what happens is this 5,000 starts to drop. As it drops, you're charged less interest on it, and therefore you are not going to have to pay this full 500 in interest. So the weekly amount you would repay to the bank would actually work out to be a little lower than that. But the maths into calculating what that would be is beyond the level of the course. So this here, the 42.31, is an approximation at best. But it's important you should know it's an approximation. It's not exactly accurate. In reality, the amount required to repay per week could be a little lower. Alright, compound interest. Again, slightly beyond the course, but worth having down because the maths is good and it's how everything's done in real life. Essentially, compound interest is simple interest happening repeatedly. So consider this example. This example is if $250 was invested at 10% per year where the interest is added to the account each year. So after 1 year, the interest is equal to the amount invested, PRT, $25. That $25 then gets put into the account. So the final amount in the account is $275. Not bad. Year 2. Once again, year 2, we add 10% interest. And this time, note that the 25 at the end of the year after 10% added on is no longer 25. At the end of the second year, it's grown. The 10% is now worth more. So a 10% jump has gone there. And at the end of the third year, we're there, etc. And so on. So what's happening is it's compounding. The interest is being put into the account, and then more interest is charged on the total amount in the account, and more in and more in. Now, needless to say, this way of calculating compound interest, subbing it in, can be very, very tedious. However, there's a little pattern that you may have noticed. The pattern is each time we're increasing by 10%, so we're using this multiplier that we've seen increasing and decreasing by percent of 1 plus 10 on 100, which is 1.1. So really what's happening is after 1 year, the amount in the account is 250 times 1.1. And then what's happening is in the second year, we're multiplying by 1.1 again, and that gets us what it's in there after 2 years. And then if we do it 3 times over, it's after 3 years. And we get this sort of formula, 250 times 1.1 to the n, where the n is the number of years. So for example, if we left $250 in the bank account for 10 years, it would end up being $648. And this is pretty cool. This is how people save for retirement. They might save up over their first 10 years of working, this with 3 zeros after it, and then leave it there for a long period of time, and it becomes a nest egg with which they can retire. That's what, if you have a job, your KiwiSaver is doing. You're putting a bit of money in now, it will compound over the lifetime and get much bigger. Now, there's a formula where the amount at the end of the time is given by the principal in dollars, bracket 1 plus the rate, and the rate's over 100, so that there is our multiplier we've seen from the percentages, times t in time, where time is in years. Alright. To be honest, you guys have watched a fair bit. I'm going to skip that example, just do this one. There's not really a lot you need to know in terms of using the formula. I think you should see it used once. To calculate the difference between simple and compound interest on a loan of $2,000 at 7% over 5 years. Well, simple first. I equals PRT. I equals PRT is I equals 2,000 times the rate times time. Is 700. So the total amount in the account at the end would be 2,700. Now note, in compound, A equals P, 1 plus R and 100 T. The total amount is equal to 2,000. 1 plus 7 on 100 to the power of 5. 2,000 times 1.07 to the power of 5. And the final amount is 2805.10. And it shouldn't surprise you that compound interest would accrue more interest, because what happens with compound is you're earning interest on your interest, whereas simple interest, you're not. Note that this works the same way as if you're in debt. So if you're in debt and have a credit card debt, you will be charged interest, and that will be further deducted from, like, you'll owe more. And if you don't pay it off, you'll be charged more interest and you'll owe more. And that's why credit cards are really very dangerous, because the amount you owe increases exponentially using this type of formula. All right, apologize that was a long one. Hopefully you got something out of it, especially Banking 101. Banks are really cool. All right, and see you in class tomorrow.